let us look at what is called the standard deviation. Now you remember in previous videos we looked at some other values, looked at the mean, the median, and the mode. Now those three values in statistics are referred to as measures of central tendency. Remember, we also looked at what is called the quartile deviation. That is called one of the measures of dispersion. Dispersion, how much the values disperse over the distribution, right? Now the standard deviation is another measure of dispersion. Very, very important and widely used in statistics, alright? So let's look at that. The standard deviation. Now, let's write down the formula for the standard deviation. But first of all, standard, alright? You have an idea what that means, right? That is really a set rule or practice, whatever you want to call it. Deviation means how far from the norm, the normal, something deviates, something strays away from. Alright? So let's look at the formula. The standard deviation. Sometimes SD is used, but sometimes the Greek letter, the Greek letter sigma, lower case sigma, is used to represent standard deviation. Is the square root of the sum of x minus bar x, where bar x represents the mean. Let me extend this a bit more. All over n. Alright. And we'll be careful to make sure that square root sign covers the n as well. I have to make sure of that. Alright. So basically, x represents each value, right? Each individual value. Bar x, of course, well, I'm putting bar x in green. Bar x. Good. That means the mean of the values. Of course, uppercase sigma means the sum of, alright? And then n is the number of values. So, of course, lowercase sigma means the standard deviation. Now, here, you're looking at the square root of the sum of, there's a square here, I didn't put on the square, the sum of each value minus the average and the square of that divided by n. Now when you consider all of this, just this part, the x minus bar x squared, and you add up each of them and you divide by the number, you're finding a mean, the mean of something. Alright? It is the mean of the square of the each item, how far each item is from the mean, and you're finding the square root of that. So this is the square root, it means a root of the mean. You add up these and you divide by the number of them of the and you see this square sign here of the square, RMS. So anybody have seen RMS before? If you did, or if you have already been doing electrical technology, studying electrical technology, you remember that RMS means the root mean square. Alright, the RMS value, the root mean square value. So the standard deviation is really that, the root mean square value. Alright, I'm going to want to look at an example. Alright, let me make some space. But just before we go into standard deviation, you do have what is called variance. And the difference between the variance, let me write it, variance or var. The only difference between the variance and the standard deviation is this. Look carefully. The variance doesn't have a square root. While you're working it out, you find the variance first, because you will have to get all of this before you find the square root. So what you find just before you do the square root is called the variance, and then when you put the square root on it and calculate that, then what you have is the standard deviation. Alright, but right now we're primarily interested in the standard deviation. Let's look at an example of standard deviation. I want you to calculate the standard deviation of 2, 4, 7, 8, 9. The standard deviation of that. Alright, first of all, we have to find the mean. What is the mean of these values? I want you to pause the video, calculate the mean. If you want to do all of it and calculate standard deviation, that would be nice, but calculate at least the mean for now and come back. So pause. Alright, you have paused and you have calculated the mean. What did you get? Let's see something. 2 plus 4 plus 7 plus 8 plus 9 all over, what is n? 1, 2, 3, 4, 5. I have 5 values here. Alright, so in calculating this is going to be 2 and 4, that's 6. 2 plus 4 plus 7, that's what, 13, plus 8, 21, plus 9, finally 9, giving you 30. So all of this adds up to 30. We're dividing by 5. So how many 5s do you have in 30? There are 6 of them. So let's just make a note here. The mean is 6. So we have the mean. Good. Oh, I don't want to erase those. I don't want to erase these at all. Alright. Now, for each, what you're going to have is x minus bar x. So what I can do here is to say x minus bar x squared each time I go along. So what I have in the first case, x is 2. In the first place, x is 2. and I have 2 minus bar x, which is 2 minus 6, and I want to square that. Remember, I'm finding the sum now, so I say plus the next value is 4 minus the mean, which is 6, and I square that, plus then I have 7 in brackets, 7 minus the mean, which is again of course 6, the mean doesn't change, and square that, plus 8 minus the mean of 6, close bracket, and square that, plus, because I'm summing up these, I'm summing up x minus bar x. Alright, what you have here, plus 9 minus the mean 6 squared. You see that? Alright, even though I have the mean up here in green, I put it down here in red using the numbers now. Now I want all of this over n. Let me use a straight line. Nice. Over n divided by n, which is 5, the number of them. So let's see what's happening now. 2 minus 6 is negative 4. Negative 4 squared. You must put the negative 4 in a bracket. Alright, plus 4 minus 6 is negative 2 squared, plus 7 minus 6 is negative 1 squared, plus 8 minus 6 is going to be 2 squared, plus 9 minus 6 is what? 3 squared. All of that, I want, that line is too wavy, I want a straight line. Good. All of that divided by 5. So negative 4 squared is 16, plus negative 2 squared is 4. Pause the video and finish that off for me and calculate the standard deviation for me. Okay, did you do that? Did you finally get the standard deviation? Let's see. Let's continue this and notice that all or each item being added will become positive, because when you square a negative number it becomes positive, right? So negative 1 squared is 1. This I'm talking about, this negative 1 squared is 1, plus 2 2's 4, plus 3 3's 9, all divided by 5. So what do you get now? Let's see, 16 plus 4, that's what? 20. 21. 21 plus 4, that's 25. 25 and 9 would give 34. Alright? So what you're going to get is 34 divided by 5. 34 over 5. What is 34 divided by 5? So I have 34 over 5. 34 divided by 5 equal 6.8. So it is 6.8. Now notice we haven't found the square root of it yet. What we did so far is each value x. So here each value, this x minus the mean, x minus the mean, these are x, all of these are the x minus the mean, and the mean of course is the 6 in each case. You see that? So that part is worked out. Then we have the square of each. When we subtract, we get this, and we square. So the 4 square, when we square the 4, you get 16. And we square the 2, we get 4. Square the negative 1, we get 1, and so on and so forth. Alright? So that's what happened here. And then we add these all up and divide by 5. That is the variance. But we finally want to get the standard deviation. We're kind of running out of space. So, you remember what these mean. So let's just erase them for a while and finish off up here. Now, finally, the standard deviation equals, I didn't want this in red. Finally, the standard deviation equals the square root of 6.8. What did you get as the square root of 6.8? Calculate it and tell me. The square root of 6.8 is 2.6. Alright? So that's the answer that you would get. Was that what you got earlier? I could say 2.608. Let's call it 2.6 for now. So it's 2.6. This is standard deviation. Alright? Is that what you got earlier when you attempted to do all of it at once? That would be nice. Now what I want you to do for me is this. Let me erase all of this. I want you to write down this formula, write down these numbers, and calculate the standard deviation of it all over again without going back. Alright, so that's your assignment for now. Alright, we'll continue in another video, and we might very well do, well, we will do some more examples of standard deviation in further videos. So I will see you then.